Right. In my last video, I mentioned that a lot of algebra is just a more abstract representation of arithmetic. Perhaps I'm going to talk a bit in this lesson or in this video about brackets, which is not strictly the type of thing you would do in arithmetic, but you could come across an example, an expression like this, for example, 2x plus 2. Now, if you wanted to get rid of those brackets, what you need to recognize is that is 2, using algebraic representation, that is 2 multiplied by this bracket. And in order to get rid of this bracket, what you would do is you multiply whatever's outside the bracket by that, the first term, and then multiply it separately by the second term. So 2 times x is just 2x, okay? 2x is 2 times x, so that's, remember that we don't use the multiplication sign, so that's just 2 times x, represented by that, and 2 times 2, which is 4. Now there is the opposite operation, which you might be given an expression like that and told to factorize it. And by factorizing it, it means introducing brackets. So what you would do is to see if there's any common factors. So I mean, and we know the answer to this already, but I'll use it as an example. We know that the common factors of that and that are 2. So I'd put the common factor out and introduce the bracket like that. And then I'd take each of the expressions and divide through by the common factor. So 2x divided by 2 is x. And 4 divided by 2 is 2. Okay, so obviously you've got back what you originally started with. But you see the technique. To get rid of the brackets, you multiply that by that and that by that. And to reintroduce the brackets, or more generally to give an expression to factorize it and thereby introduce brackets, I would search for a common factor, which here is 2, and 2, introduce the brackets, and then divide each of the expressions by the common factor, that by 2 and that by 2. And I'll drag the sign down. Now, what can get bit confusing in this is when we introduce negative numbers. I think that's probably a real bugbear. So if I had some expression like this, you're using the same thing, same rule, but you have to remember that this is minus 4. Okay, so you remember your rules about what happens when you multiply with an expression that involves minus numbers. That's unnecessary. That'll just stay as it is. But that's now minus 4 times x, which is minus 4x. Okay, minus times a plus is a minus number. Remember that that's just like numbers. If I had to solve number 3, that's really plus 3. So if I have an x. If I have an x, that's really plus x. So it's a negative number multiplied by a positive number gives a negative number. And then it's minus 4 times plus 9, which equals minus 36. Okay. Now, well, I can mention in passing how you'd again, if I was to follow this pattern, I'd look to factorize it back again. I would look for a common factor, which I know is minus 4. Insert the brackets. Divide that by minus 4 is x. Okay, a negative number divided by a negative number gives a positive number. Divide that by that. Again, same rules. 9. So it's the same rules as up here, but the real nasty thing is the negative signs. So you need to be happy with the arithmetic processes. I mean, that's what I said before originally, that you need to be really happy with the arithmetic processes. So you need to be happy with the ideas of multiplying negative numbers by positive numbers and negative numbers by negative numbers and so on before you embark on this. Otherwise, you're going to be asking for setting up trouble for yourself, and I think that's really where this idea that algebra is a hard subject stems from, because you haven't sort of done the arithmetic and mathematical preparation for the topic. So again, I proceed by example to a slightly more difficult one, 6x minus 6. Same idea, that 4 is superfluous really, stick it down there. Minus 6 times x is minus 6. Minus 6 times minus 6, now that's plus 36. A negative number times a negative number equals a positive number. Now if I was to do the opposite operation, by analogy with the factorization well, I talked about factorization in another form before, where I said you could, if you can't, you can either do it in one go or you can do it in stages. So I mean, if you didn't see the common factor of 4 straight away, you could say, okay, 2 is a common factor. You could then do the same thing with 2 and then realise that you can factorise it further, and then eventually get this form here. So you don't need to, you know, you can do it in stages if that if needs be. So if you were to work backwards from this, you could I would say, okay, there's a common factor there of say 6, or there's a common factor of minus 6. I mean, so you've got a couple of ways to do this. If I said, okay, there's a common factor of 6, so I'd say 6, take the out. Divide that by 6, that'll give you minus x. And divide that by 6, that'll give me plus 6. So nominally, I seem to have got a different expression than before, but actually, what I can do is I can take a well, this one could be getting a bit more complicated here, but what I'm saying is that that expression there is equal to that expression, although it doesn't obviously doesn't look the same. What I can do is I can take out a common factor here of minus 1. I can say, okay, minus 1. So that'll be x minus 6. No, I've done this wrong. Okay, don't worry about too much about this at the moment if you don't follow it. What I'm really trying to stress is that there are you could end up with an expression when factorising that looks different from, say, someone else, but is identical. That's if you're dealing with negative numbers. I can take a factor of minus 1 out to produce that expression. I can then multiply that by that. So it becomes 4 minus 6, x minus 6. So it's as before. Yeah, I don't want to go, if you don't understand that too much, I don't want to go into too much detail for the moment. But yeah, have a look at it anyway and see how you feel. That's been crossed out. That was my mistake. So other examples like this are very much as before. It's just more complicated. 6x x squared plus 3. Well, 6x times x squared is 6x cubed. That might be that's another rule for algebra, but it's based on an arithmetic rule which we've used already. That 10 to the power 2 times 10 to the power 3 equals 10 to the power 5. You just add up the indices. So really, well, again, you need to realise that there is really a number 1. That's just x is really x to the power 1. So it's x to the power 1 times times that, following this rule, is just x to the power of 1 plus 2, which is 3. That times that is 18x. So you can imagine that in examples, they start off with simple examples, just like I started off with, and they just get progressively more difficult. But they're applying exactly the same rules throughout. There's a special case, I don't know whether I should say this actually, this a special case, something like this, x minus 9 or something like that. Now, really, again, to extend the rule that I've just mentioned in various different forms before, there is really a 1 there, okay? What have I mentioned so far? I've mentioned the fact that that is really 1x. I've mentioned the fact that that really is equal to x than 1. That's really equal to 1x. So really, 9 minus x minus 9 is really 9 minus 1 x minus 9. No, I'll leave that out. Sorry, I'm crossing that out again. Yeah. Yeah, sorry, I don't really need that there to do it at all, do I? 9 minus 1, x minus 9. So there is really a 1 there. Previously I had 2 or 3 or whatever it was, but there is really a 1 there, but by convention it is left out. Sorry the mess I'm making here. Again, those are crossings out. It's just 9 minus 1 times the bracket. So you could say, okay, minus 1 times that, and minus 1 times that. That would be the standard way, in line with what I've just said. There is a special rule when dealing with this, which I state this as a special rule with the hope that I don't actually confuse you. But when there is really a 1 there, which really expresses itself as actually nothing being nothing there at all. If it's in that form, okay, where you've got nominally nothing in front of the bracket, or really a 1 in front of the bracket, what you can do is you can get rid of the brackets and reverse the signs of everything inside. So 9, I'll get rid of the brackets now, and I'll reverse the sign of that. So that becomes, well, I should really have left that off and said 9. I'll get rid of the brackets, I'll reverse the sign of that now, and I'll reverse the sign of that. And that's your answer. I mean, you can test it by doing the long way around. If you insert a minus 1 in there, if you just insert a 1 in there and do it the way I recommended, minus 1 times that gives you minus x, and a minus 1 times that gives you plus 9. So it's in accord with the basic method, what I've called the long method that I've just introduced originally. But for this a special case like this, you can just do that. Get rid of the brackets and reverse the signs of everything inside the bracket. That's just a quick way. You have something like 4 minus x plus 3. What is that? It's 4. Reverse the sign of that, reverse the sign of that, and that's your answer. Yep. So, yeah. So that's just a brief introduction to that particular skill that you need to do in algebra. Anyway, cheers for now.